BIPM notification, we had over 1,000 subscriptions, which actually overran the BIPM's, if you like, seating on this webinar. So that was why the decision to live stream was taken. And if you have people who are still interested in attending and they can't get on, they contact you, please direct them to the registration page, and the links for the 2 live streams to YouTube and LinkedIn appear there, and they should be able to see us as we're talking right now. In terms of just some logistics, perhaps to advise those of you who are not so familiar, we are in what is known as a Zoom webinar. In the Zoom webinar, unlike a meeting, you cannot see everybody. And the reason that was done was because this is really a presentation more than a meeting. So if you're expecting to see lots of little blocks and be able to find people, unfortunately, as a participant, you probably won't be able to do that. We'll get to it a bit later when we get to point 5 of the agenda, which is the question and answer session. The chat has been disabled. Managing a chat with 3 or 4 or 5 or 6 or however many hundreds of people who will be on this webinar is virtually impossible. So I would ask you to refrain from chat kind of information. The way to, in fact, communicate your concerns, perhaps, or questions for clarification should be done via the Q&A. If you hover your mouse over the screen, you will see at the bottom there is a tag marked Q&A. It has a question mark on it. And if you tap on that, you will be able to, in fact, put in a question and or a comment. And I might say that, all of those will be taken into account by both working groups, post this particular webinar. So even if you don't have a question, please treat the question as also the possibility to comment. We're not expecting necessarily always questions, but comments will also be gladly accepted. The other thing I quickly want to just tell you is that for those of you perhaps who are not that familiar, you might wonder who the JCGM are. And I thought it would just quickly to tell you that the JCGM and JCGM stands for Joint Committee on Guides in Metrology. And there are 2 working groups. One deals with uncertainty, that's Working Group 1, and is chaired by Walter Beck. And the other is Working Group 2, which deals with the VIM, the VIM, and that is in fact chaired by Chuck Ehrlich or Charles Ehrlich. Both of these gentlemen, as chairs of those 2 working groups, will be making presentations in items 3 and 4. And you will hear the rationale for the change from Walter, and you will also hear some, if you like, counter arguments being presented by Charles and some of the difficulties that Working Group 2 see in the change that's being recommended. Thereafter, we will go to a question and answer session, and in that session we will try and provide a number of what we think will be duplicated questions perhaps, but some key ones we'll try and sift out of the ones we receive to be answered by both Walter and Chuck, as well as there are perhaps some other panelists who are joining us today as well, and I'll introduce them a little bit later. Please stay on, because the most important part of this is actually to gauge the interest in the change. And you will notice under item 6 that there are poll questions. Those poll questions will appear via an app called Menti, M-E-N for Nelly, T-I, Menti. And there will be 2 ways to get onto it. I will repeat the information when we get there. There will be a QR code, so you can log on via your mobile phone if that's handy, or you can go to menti.com and you'll be able to, with a code, log in and answer the questions. I will repeat this information when we in fact get there. So without further ado, and getting on with the business at hand, I'd like to introduce Martin Milton, who is the director of the BIPM and chair of the Joint Committee on Guides in Metrology. Martin, over to you.
Thank you very much, Steve. As Steve says, I'm Martin Milton. I'm the chair of the Joint Committee for the Guides on Metrology. The Joint Committee for Guides on Metrology brings together 8 organisations, and as Steve says, produces 2 very well-known publications essential for many communities: the GUM, the Guide to Uncertainty in Measurement, and the VIM, the International Vocabulary for Metrology. Now, we're organising this webinar today because the 2 working groups of the JCGM have come up with a proposal for a new definition for measurement uncertainty. I wonder if we can have the next slide. So here we are. So this is the substance, the motivation for our webinar today. On the left there, and I'll read it through, is the definition of measurement uncertainty, which I think the wider community is very familiar with over many years. This definition is that measurement uncertainty is a non-negative parameter characterizing the dispersion of the quantity values being attributed to a measurand based on the information used. Now, historically, there are different routes for the publication of this text, and some include the term non-negative at the beginning and some don't. I think Chuck Ehrlich and Walter Beek will comment on that. On the right, we have the proposed new definition, which is the subject of today's webinar, and which Chuck Ehrlich and Walter Beek are going to explain and motivate our change. This proposed definition would be that measurement uncertainty is doubt about the value of the measurand that remains after making a measurement. So today we'll hear from both the chairs about that. Now, we know that a change to a definition as important as this is of interest and even concern to the community that we work with. So I wanted us to hold this webinar so that we can get at least a snapshot of views on the definition. Today is not a formal process. We're not taking votes from member organisations and deciding on a majority. Today is an opportunity for our 2 working groups to see some texts introduced by you into the Q&A and to see the results of the poll we're doing today. So after the webinar, the 2 working groups will reflect on the snapshot we get today, and they'll consider, on the basis of that, whether they would include the proposed new definition amongst the text of a proposal for the 4th edition for the VIM. Now, of course, approving a new edition of the VIM has a formal process. In fact, we started working on a 4th edition of the VIM some years ago. We circulated a draft in 2021 and received around 1,500 comments. We revised the draft and circulated it again in 2023, again with around the same number of comments. So after today's webinar, the 2 working groups will reflect on the feedback and take a view as to whether they would seek to introduce this definition amongst the texts in a future circulation of a 4th edition of the VIM. So today is informative, it's not formal, it doesn't change the fact that we still use a formal process. I'd like you to think of this as an extra consultation step, also a little bit of an experiment as to whether a webinar like this is an effective way to get views from the community into the groups that work in the JCGM. So that's an introduction from me. I'd like to hand over now to Walter Beek, who is the chair of Working Group 1, the group responsible for the GUM, the Guide to Uncertainty in Measurement. So over to you, Walter. Walter seems to have some problem. Are you there, Walter?
Please unmute yourself, Walter.
Can you hear me now?
We can hear you. Thank you, Walter.
Thank you.
Over to you.
So thank you. I take the screen. Okay. I hope you can see my screen now. So here we are. Proposed new definition for measurement uncertainty. Now, the first question is, why a new definition? I'm just trying to, okay. Why a new definition? There are essentially two reasons. The first reason is that I never could discriminate between the meaning of the definition of measurement uncertainty and that of the definition of standard measurement uncertainty. The current definition says non-negative parameter or simply parameter, and for measurement uncertainty. And the definition for standard measurement uncertainty reads measurement uncertainty expressed as a standard deviation. Now, standard deviation is, again, a parameter. So I never could really understand the distinction between these two things. So I think, and we think, that there is an ambiguity in the definition of measurement uncertainty, and so there is a need for disambiguation. The second reason is perhaps more important. The legacy GAM definition as a parameter is good for a scalar measurement, I mean with just one measurand, expressed by a measurement model which behaves sufficiently well, in which the uncertainty for the input quantities are sufficiently small, in which the nonlinearities are sufficiently well controlled, and so on. However, in modern metrology, you have many measurements which are not that simple. The first example that comes to my mind is multivariate measurements, a case in which you have to determine a number of measurands using common equipment. The simplest example is the calibration of a set of weights. And in this case, one single parameter is no longer sufficient. And this is not a new problem, of course, but the legacy GAM was written essentially for a scalar measurand. And there is just a little mention to the case of multivariate measurands. So this is a point. Other points, we have inverse problems. We have problems which can be solved just using algorithms, which are difficult or impossible to write down explicitly, and this is acknowledged as well in the scope of the legacy GAM. We have Bayesian inference, which is pervasive in all the modern measurements, from determining the mass of the black hole that was measured some years ago to the radius of the proton and so on. And then we have artificial intelligence, and we have to express the outcome of artificial intelligence tools in some way, for example, in classification, and so on and so forth. So the feeling is that the definition of measurement uncertainty simply as a number, a parameter, is insufficient. So the second need that motivates a new definition is a generalization of the definition. Now, this is the definition: doubt about the value of the measurand that remains after making a measurement. This definition is due originally to Antonio Pozzolo when he was a member of Working Group 1. Antonio is now the chief statistician of NIST, and as far as I know, this definition is now part of the quality manual of NIST. We had, within Working Group 1, very long discussions about the term doubt. And I know that somewhere in some quarters in our community, there is great hostility against this word. At the time of the discussions, I was relatively indifferent between doubt or uncertainty, and then we voted, and doubt prevailed by a narrow margin. Then I was curious, and I went to see at a dictionary. This is what I had on the hand, 1961. This tells you how old I am. So anyway, doubt. I searched for doubt and I found uncertainty of mind, not feeling sure, a state of uncertainty. Then I went even more curious and I searched for uncertainty. And the response is uncertainty, doubt, the state of not being sure. So the two terms are, in English at least, essentially equivalent. And this fact is also acknowledged in the legacy GUM. The word uncertainty means doubt. Yet, we perceive that there is stronger opposition against doubt than against uncertainty, because although both carry a negative connotation, of course, doubt is deemed to be more negative than uncertainty. You might know that in the past there was some attempt to express measurement uncertainty in a more positive way, something like accuracy, for example. But the usage of the term is so rooted within everyday practice that it is absolutely impossible to change it now. Anyway, what I want to say is that there is a risk that a very good definition in my mind is rejected just because of the hostility against the single word doubt. In this respect, and considering that Working Group 1 at that time was very hesitating between the two terms, please do not concentrate too much on this doubt and consider that it could be interchanged with uncertainty, depending as well on the outcome of this webinar. Now, a second consideration always taken from the GUM is that in this guide, the word uncertainty without adjectives refers both to the general concept of uncertainty and to any of all quantitative measures of that concept. So here there is a second sign of this ambiguity I mentioned earlier. Now let's go a little bit deeper into the definition, and I will try to, well, to tell you the merits of the definition as we can see them. Doubt. This is the first thing. So in this definition, measurement uncertainty is a state of mind. This is important because I heard in the past, in the many years I worked in metrology, people thinking that you try to estimate uncertainty in the sense that there is, for a given measurement, for a given estimate of the measurand, there is a true uncertainty that you are trying to estimate somewhere. So this true uncertainty would be nature. So this implies that there is an uncertainty of the uncertainty, and so on and so forth. And the process could be iterated endlessly. So you would have the uncertainty of the uncertainty, and so on and so forth. So we think that this is nonsense. So it is by far better to consider that the uncertainty is your doubt. When I say your, I imply a subjective state of mind. Now, here again, I see that there is a position. We all would be happy to have the data to speak by themselves with no intervention from the experimenter. But this is a dream. This is absolutely impossible. Consider, for example, a case in which you have to evaluate from a datasheet something which enters into your measurement model. And so you have perhaps the maximum errors of that thing, of that instrument or whatever. So, or even a coefficient, a thermal expansion coefficient you find in a manual. You have to assign a standard uncertainty to that quantity. And the optimist could use a triangular distribution. The conservative might use a uniform distribution. So this is to say that given the same information, subjectivity enters and cannot be avoided. People might be unpleased by this fact, but this is a fact. So a state of mind, there is no a true uncertainty in nature. Well, don't misunderstand me. We always fully recognize that there are random processes in nature, but we are not talking about that here. We are talking about well-defined measurands. Okay, so this is the situation, and in this situation, there is no a true uncertainty in nature somewhere to be evaluated. This, incidentally, is the reason why we tend to prefer the term evaluating uncertainty rather than estimating uncertainty. Okay, estimating uncertainty conveys the idea that uncertainty itself is a sort of a measurand, which is not true. Okay, so this is the first point. This is a state of mind, and this is subjective. Measurement uncertainty is here the concept. It is not its quantitative expression. It is not a parameter. What is the consequence of this? We separate in this definition measurement uncertainty, the concept of measurement uncertainty, from its quantitative expressions, from the ways in which you express it with mathematical tools. So incidentally, this has a beneficial effect on an old problem. You know that one of the reasons for Chuck will be better than me in that, but one of the reasons why the CIPM promoted the development of a fourth edition of the VIM was the inclusion of nominal properties or categorical data, as you prefer. So I think that the operation is called examination. This is out of our discussion today, but it is worth mentioning that with the existing definition of measurement uncertainty, which is quantitative, you cannot easily extend the definition to a corresponding examination uncertainty for categorical data. With this definition, it is very simple, the operation. It becomes simply doubt about the value of the examinand that remains after making an examination. This is especially relevant for AI outcome, which is typically applied to classification data. So since we all recognize the importance of attaching an uncertainty to the AI outcomes, and in classification as well, and perhaps particularly, this generalization of the definition makes things easier to carry on. Now, let's go on about a second point. Doubt about the value of the measurand that remains after making a measurement. The value. Well, the original definition, the NIST definition, is explicit, the true value. We dropped with the term, the adjective true, but the meaning is exactly the same as you will see in the notes accompanying the definition. When I enter metrology, you couldn't mention true value and error under unless you were classified as a troglodyte in philosophy of science and so. The GAM itself, the legacy GAM itself, says that these two concepts are not used because they are considered idealized, unknowable, and so on and so forth. But at the same time, the GAM says that this document is explicitly concerned with the measurand, which is sufficiently well defined that can be considered, its value can be considered essentially unique. So on one side, the GAM is ambiguous. The legacy GAM is ambiguous in this respect. We wanted to be explicit and to restitute the true value, the value it deserves. It is a fundamental element in the estimation theory, which is what what you use every day when you evaluate a when you calculate the result of your measurements. So this concept of true value is strictly connected with the concept of a real number. We are still using real numbers. Perhaps in the future there will be better ways to convey the information, but for the moment being, we are confined to using real numbers. When you write your measurement model, y equals something, that y is considered as a real number, and the real number is, as you know, a point on the axis of the on the real axis. So, and in addition, perhaps the most important, I need to move this thing somewhere. Perhaps most importantly, it is not true that the true value is unknowable. There are several cases in which you can know it, and a smaller number of cases in which you know it exactly. All quantum, well, many quantum quantities, the spin of an electron is perfectly, we don't doubt that the spin of the electron has a true value. Even more, we know it exactly, and this is due to the revision of the SI when the Planck constant was given an exact value, because many forget that the spin of the spin is not a number. In the SI, the spin is a number multiplied by the Planck constant. So similar to the spin, many other quantum quantities do have a true value, and we believe that they do have that. Of course, we know the indeterminacy principle and so on and so forth. We know that we don't know anything before making the measurement, the collapse of the wave function and so on. But once you have made your measurement, you can know the true value. And another interesting point is when, for the counting measurements by counting, counting is considered a form of measurement. So it is a measurement in its own right. Okay. So when you count something, the number of laps I ran in a swimming pool, the number of eggs in a can, the number of people in a stadium, the number of atoms in a silicon sphere, and so on and so forth, you have no doubt about the existence of that true value. And, for example, in the case of a number of eggs in a can, you can know it exactly. So I think that it is important to reevaluate the concept of true value. Now, doubt about the value. Further important point. It is not a value. It is the true value. Because in estimation theory, the true value is unique. So not only it does exist, but there is, in estimation theories at least, there is not a set of true values. And the definition is quite explicit in that. Now, we know that this notion is controversial. A beloved example is the thickness of a sheet, be it of metal or paper. But the thickness of a sheet, if you measure, of course, if you measure it in different points, you get different values. But this means that the thickness of a sheet is what we call an ill-defined measurand, because behind this apparently innocuous measurand, the thickness of a sheet, there is a population of values. So perhaps a more interesting and more relevant example is the atomic mass of carbon. Now, carbon is an element which has several isotopes, and whichever sample of carbon has its own isotopic composition. So what happens is, this is a real case. We were asked by the Commission on Atomic Weights and Isotopic, I don't remember the name, the one presided by Iris Meyer, which has been a member of the working group as well. We were asked to evaluate whether the uncertainty was declared correctly and so on. So the point is that you can measure the atomic weight of a sample or mass of a sample of carbon, which with an uncertainty which is much smaller than the dispersion of the possible values of the carbon you find. So again, you have a situation in which there is a population of things whose spread is by far greater than the accuracy with which you can measure each individual element of that population. It is like asking, give me the height of an Italian. In a sense, it is an impossible question to answer. A way to answer, of course, is given by the gum. Again, in any case, if the phenomenon, this is the gum, the legacy gum, if the phenomenon of interest can be represented only as a distribution of values, and this is the case of the atomic mass of carbon, or of the height of an Italian, or of the thickness of a sheet, or is dependent on one or more parameters, such as time, then the measurements required for its description are the set of quantities describing that distribution or that dependence. So this is, in our opinion, the correct way to deal with the uniqueness or non-uniqueness of the true value. Going on, we have doubt about the value of the measurand that remains, etc. This is a further important explicit point. The doubt is about the measurand. The doubt is about the true value of the measurand given the estimate. It is not about the estimate. Again, this is a controversial point. And the argument is, yes, but if I make a different measurement, the estimate will change. So what is variable is the estimate, not the measurand. Of course, the measurand is fixed. It has a unique true value. But as we see the situation, the measurand, what you know about the measurand is represented by a distribution of possible values. Okay. When you take one of these from the lake of possible values, what we were taught at school, an indication is something taken at random from a series of independent and identically distributed values from a distribution, and so on and so forth. When you pick one of that is a realization of that random variable. And the realization of the random variable is a number. It has no uncertainty at all. So the important point is the doubt is about the measurand, given the estimate. So the estimate is the only sure thing you have. And this is, again, one of the merits, I think, of the definition. It clearly declares what we think about measurement. Now, doubt, this is a further point, doubt about the value of the measurand that remains after making a measurement. This definition is very good, but measurement, as it is currently defined in the VIM, is the process of experimentally obtaining, etc. Now, taking again the example of the type A evaluation, type B, sorry, evaluation I gave earlier, when you need to associate a standard uncertainty in a type B evaluations, taking it, as I said, from a handbook, for example, for a thermal expansion coefficient and so on, this is not exactly a measurement. So this experimentally in the VIM should be weakened in some way in order to encompass type B evaluations of the kind I tried to describe. So that's more or less all as concerns the proposed new definition. But what is fundamental to understand it are the notes. Note 1 says that for the purpose of this definition, the term true value of the measurand is not used because the word true is viewed as redundant. We did nothing more than copying from the legacy gum, because there is a sentence which is almost the same in the legacy gum. So the legacy gum as well, although they on the one hand try to demonize the true value and error because they are idealized and so on and so forth, with this sentence they implicitly recognize that, well, the document accepts the concept of true value, uses the concept of true value. Note 2, measurement uncertainty can be described fully and quantitatively by a probability distribution on the set of possible values of the measurand. This is what we call state of knowledge probability distribution. So I give you a probability distribution and I tell you I trust that the true value is somewhere lying there behind this probability distribution. But even more, I can tell you the probability that it lies within any given interval you ask me. Or if you give me a probability, I can give you a number of intervals called coverage intervals, as we know, within which the measurand lies with that specified probability. So this is the most complete way to describe the probability distribution. The measurement uncertainty. Doubt is described by a probability distribution. My doubt. Now 3. For scalar measurands, measurement uncertainty can be summarized by, for example, the standard uncertainty, well known, coverage interval with specified coverage probability, well known again, or by selected quantiles of the probability distribution in note 1, the previous one. For multivariate measurands, measurement uncertainty can be described, for example, by the covariance matrix, or by a correlate region with specified coverage probability. So, measurement uncertainty now encompasses a number of mathematical tools we can use to describe it in a much wider range of problems than those allowed by the definition as parameter. So, key takeaways. The concept is now separate from its quantitative expressions. There is no longer ambiguity. And this allows, as well, a broadening of the scope of the definition. Measurement uncertainty is now an overarching concept that accommodates a variety of mathematical tools used to express it, standard uncertainty, and so on and so forth. Another advantage of this definition is that it is easily transferable to categorical data properties as examination uncertainty or classification uncertainty in AI. And so to conclude, how do we express doubt with the new definition about the value of the measurands? We use standard uncertainty, coverage intervals, which include expanded uncertainties as a special case, covariance matrices, coverage regions, probability distributions that can be continuous or discrete, and the discrete case is especially important in classification problems, and possibly more. We had the example of the characteristic uncertainty proposed by 2 colleagues some years ago. So it is exactly as we already do. So since these definitions of standard uncertainty, coverage intervals, and so on and so forth are unchanged, nothing changes on current laboratory practice. So the main advantage of this definition, it is a better clarification of the concepts with no impact on everyday's life. And this is the end of my presentation. Thank you. And I now stop sharing the screen.
Okay, thanks, Walter. I guess you'll turn it over to me. Okay, very good. I can't hear you. You're muted now. Okay, you're muted now, Walter, but that's okay. Okay, I will. I'm Chuck Ehrlich. I'm the convener of Working Group 2, as you've heard, and I will share my screen and give you the perspective of Working Group 2 of the VIM committee about this, about what is being proposed. Let me go to the slideshow mode. There we go. Okay, very good. Okay, so thank you very much, Walter, for your presentation, and I'll add the VIM committee perspective. But before I do, let me begin by adding my thoughts and appreciation of our dear colleague, Clemens Elster. As was mentioned earlier, he'll be dearly missed by the VIM committee as well. So we've now heard from Walter about the GUM committee's rationale and proposal for explicitly redefining measurement uncertainty to be a subjective or non-mathematical or psychological entity, choose your word, such as doubt, rather than a mathematical or quantitative entity, and that is as a parameter, as it's been defined in the GUM and VIM for more than 30 years now, as we've heard. And the VIM committee recognizes that the GUM committee should have jurisdiction over how the concept of measurement uncertainty should be considered and defined, and wants to be supportive of our GUM committee colleagues to the maximum extent possible, while remaining consistent with the internationally accepted rules of terminology and vocabulary development in ISO IEC 704 and 1087. And this includes self-consistency of definitions and adherence to the substitution principle, which I'll explain in a minute. So most importantly, from the VIM committee's perspective of vocabulary, is that what's being proposed here would be to associate the term measurement uncertainty with a different concept than it has been associated with in the past, which, as we all know, has been a quantitative concept. And this has significant ramifications in a vocabulary that I'll elaborate on. In fact, I'll elaborate on what Walter said a little later. Actually, some other definitions will need to change, and I'll explain that. So, and this is why we appreciate the opportunity to have this webinar, to gauge the acceptance by the general metrology community of this proposed change in usage of the term measurement uncertainty before incorporating this change into the next committee draft of the 4th edition of the VIM. Now, the GUM and VIM committees have been meeting jointly about this for a couple of years now, on and off, and the VIM committee members can, for the most part, go along with this proposed change as long as there are notes accompanying the new definition that recognize the historically quantitative aspect of use of the term measurement uncertainty. And we heard Walter discuss this, and I'll elaborate a little further. Okay, so as you've now seen from Martin and Walter, here's the proposed new definition. And the last new note does reference the quantitative aspect, is shown here in light blue, which you heard from Walter, which says that measurement uncertainty can be summarized by a standard uncertainty or a coverage interval. So that's a good thing. However, there are several entries shown here in the second committee draft of the VIM-4 that are related to measurement uncertainty, but that are quantitative. And the intention is to keep them as being quantitative. Everybody seems to agree with that. And so the definitions of several of these entries would also need to change in order to keep them as being quantitative, while at the same time keeping them consistent with the new subjective definition of measurement uncertainty. And let me use the first entry, standard measurement uncertainty, as Walter did, to explain what I mean. I'll use it as an example of what we would need to change in the VIM-4 to accommodate the new definition of measurement uncertainty while keeping standard measurement uncertainty quantitative. And at the same time, I'll explain the substitution principle. So here I show the definition of standard measurement uncertainty, as Walter showed, as it appears in the VIM-4 second committee draft. Measurement uncertainty expressed as a standard deviation. Now, if I were to substitute the proposed new definition of measurement uncertainty into this existing definition of standard measurement uncertainty, which the rules of vocabulary construction say I must be able to do according to the substitution principle, then the definition of standard measurement uncertainty becomes, shown at the bottom, doubt about the value of the measurand that remains after making a measurement expressed as a standard deviation, which would make standard measurement uncertainty also a subjective entity, which no one wants. So in order to get around this problem and keep standard measurement uncertainty as being quantitative in the VIM-4, it would be possible to redefine standard measurement uncertainty as standard deviation expressing measurement uncertainty, as shown here in green. And while this interchange of the order of words may seem to be a somewhat subtle change, defining standard measurement uncertainty this way would allow standard measurement uncertainty to remain quantitative as a standard deviation, while measurement uncertainty could be subjective, as is being proposed. Now, a similar approach can be taken for most of these other entries in order to maintain them as quantitative entities. And the VIM committee and GUM committee have been working together to come up with revised definitions for these entries to maintain them as quantitative entities. However, it might be necessary for some of them, such as definitional uncertainty, target uncertainty, instrumental uncertainty, to use the term quantified measurement uncertainty in the revised definitions in order to keep those entities as being quantitative. But proposing to do this has also become somewhat controversial. So this is part of the difficulty that I mentioned earlier for the VIM committee in going to the proposed new subjective definition of measurement uncertainty. Now, the VIM committee recognizes that the original so-called legacy GUM discusses measurement uncertainty as doubt in a few places, as we've heard from Walter, but then defines it formally as something quantitative, that is, as a parameter, as we heard from Martin and Walter. The VIM committee, let's see, well, the second and third editions of the VIM do not discuss doubt, okay, and include only the mathematical definition of measurement uncertainty as a parameter, as shown here for the VIM 4 second committee draft, which derives from the legacy GUM and VIM 3 definitions. So the VIM committee recognizes, however, as Walter mentioned, that parameter is somewhat specific and therefore a less than ideal primitive term in the definition of measurement uncertainty, and so is quite open to providing an alternative definition. Now, the VIM committee recognizes that for many of you, this is your first exposure to this proposal to define measurement uncertainty as a subjective concept. And so we want to proceed cautiously when deciding what definition and notes for measurement uncertainty to include in the circulation of the next third committee draft of the fourth edition of the VIM. And accordingly, as has been discussed earlier, the VIM and GUM committees would like to explore with you during this webinar whether or not there's general support in the metrology community for associating the term measurement uncertainty with this proposed new definition. And to this end, there will now be opportunity for you to pose written questions using the Zoom Q&A feature, as Steve explained earlier. And Walter and I will do our best to answer as many as there are time for. And then after the Q&A, there are a couple of brief poll questions that we would appreciate receiving your answers to using the platform, Zoom platform and others that Steve mentioned, in order to aid us in deciding how to proceed. I guess it's not the Zoom platform, it's a different platform, but Steve will elaborate on that. Okay, so with that, I'll conclude my remarks and turn the webinar back to Steve, who will explain and host the Q&A session and later present the poll questions. So thank you very much, and I look forward to receiving your questions. So let me stop sharing, Steve. Okay, so back to you, Steve.
Thank you. Thanks very much, both yourself, Chuck, and Walter earlier, and of course, Martin, for the introductory comments. Ladies and gentlemen, you will have noticed that the Q&A has been rather active, and some panelists from the Working Group 1 have provided some comments, answers, in some cases some questions. I think most of the comments are really comments rather than questions. However, what I would like to say is that I think that perhaps I should start off by encouraging you to ask some questions if things are still not clear. That's the first thing. The second thing I'd like to suggest is perhaps the panelists who provided written answers perhaps might like to feel encouraged to elaborate if they feel the need beyond what they've said in words there, and this will give hopefully some people encouragement to add some more comments. But I think that would be a good start. So let me start, if I may. Steve Ellison, perhaps is there anything you'd like to elaborate on that you feel would be a clarifying point to what you've said in words, what you've typed out there, Steve?
I guess it depends which question you're referring to.
Okay. First of all,
several of my answers have been around the comments that have said that doubt will effectively undermine public trust in science.
Yes.
First, to an extent, we don't know. It's a change, but whether it's a change that will help or hinder is a very difficult question to answer. What I have said is, first, that in my experience back in the mid-90s, when the gum first came out and we were first talking about putting measurement uncertainty on test certificates in chemistry, biology, and clinical measurement, that word uncertainty was extremely unpopular. The reaction of the community was extremely negative. It still is not very popular, but it has become part of the landscape, as it were. Originally it wasn't. It was a new term, a very unfamiliar term, and you still hear anecdotes about court proceedings that are adversely affected by reference to measurement uncertainty. So we do know that the choice of wording can have an effect. The thing is that it's the term that has the effect, because that's what appears on the certificate. Nobody has ever said that parameter describing dispersion of values has had an adverse effect on trust in measurement. And that's because nobody outside metrology ever gives the definition. So how we decide to talk about, how we decide to define the term as a working definition for use inside metrology doesn't really reach the outside world. It's the term that reaches the outside world. The other thing is that all of the other terms, and that I haven't discussed all of these in great detail so far, terms like standard uncertainty, expanded uncertainty, perhaps a new term, uncertainty interval, none of these are changing fundamentally in their interpretation or meaning, and none of them refer to anything other than measurement uncertainty. So none of that will change. So I think while metrologists might be used to uncertainty as a term, the outside world isn't still, and that has as much adverse effect on the outside world as doubt. If we can get away with measurement uncertainty as our term, I say get away with it. If we can confidently use measurement uncertainty as a term, that won't change. I don't think that trust in science will be changed very much by a definition that very few people will read, and those that do are metrologists. So that's the main point that I've been making.
Thank you, Steve. I want to just perhaps reflect on the fact that right at the beginning, our colleagues from the PTB mentioned that the following. I'll read it out in case, especially for people on the live stream, to say a first survey of views at the PTB on the proposed new definition of measurement uncertainty gave no indication of strong objections. Besides some discussion on the word doubt, and we've heard some discussion now both from Walter and from Steve, acceptability was expressed generally and the broadened scope was praised. I'm trying to make this neutral. I don't want to be seen to be favoring one or the other. So that was the one thing. And the other thing, there was an expression of thanks from a number of people about this form of the proceedings, as well as an acknowledgement of thanks by Antonio Pasolo. So I just wish to, about reference to that Walter made. I then also wanted to ask, I found something that I think might both Walter and Chuck, you may like to comment on. And this is sorry, just let me find it. This is one of the problems with doing it this way. It's hard to, there we go. There is a question by Christian Muller-Skoll, who have said here, I have not understood why the simple substitution into standard measurement uncertainty is not possible. So I think this does more reflect, Chuck, to your side, but perhaps, Walter, you might like to comment as well. So Chuck, let's start with your response to that.
Okay. All right. Thank you. And thank you, Christian, for the question. Let me, before I do, let me just add, since I didn't comment on this discussion about the term doubt, let me just add one thing, which is that I have found such a wide range of views. Some people feel the term doubt and uncertainty are synonymous, as we've seen. And I've seen a large number of views, just the opposite, as Walter mentioned, about the negativity, more negativity associated with doubt. So I'd say, I would just say there that there's just it depends how you were brought up, basically, as to how you feel about it. So I just want to throw that out there. But to Christian's question, maybe if I wasn't clear about it, I could share my screen again if necessary. But the point, Christian, is that the current definition of standard uncertainty begins with the term measurement uncertainty. And so if measurement uncertainty becomes subjective, psychological, non-mathematical, any of those things, then the way definitions work is what begins the definition is the primitive. It's the primitive concept. And so one would be making the definition of standard uncertainty subjective because it begins with measurement uncertainty. And so the point of rearranging the words in the definition to begin it with standard deviation expressing measurement uncertainty, then it's all right if you substitute in the subjective definition of measurement uncertainty, because the primitive part of the definition is standard deviation, which is something quantitative. So as I mentioned, it's a somewhat subtle point, but these are the kinds of things that we have to deal with in the VIM committee. We need self-consistency, and the substitution principle needs to be adhered to. So I hope that explains adequately your Christian, what I was saying. Okay, so that's my input into that, Steve. Thank you.
Thank you, Chuck. Walter, do you have any comment that? I mean, I think it was mainly directed at Chuck, but perhaps just to give you the opportunity. And you are on mute, so please. Oh, there you go.
Yes,
Thank
yes.
you.
Thank you. Well, I'm not good with the subtleties of a vocabulary. So having said that, I don't see anything strange in expressing numerically doubt. So whether standard uncertainty is, of course, a mathematical thing, okay, but it is used to express a state of mind. So I don't see anything worrying or whatever in that. So if the minor proposed change to the definition of standard uncertainty fixes the problem on which I'm not especially sensitive, let's say, so all the best.
Okay, thank you, Walter. I'd like to move us a little bit different, take a different tack, if I may. The CCQM through Robert Wielsgosch has put in quite a large comment, and if my screen would not jump around, I could stay on the same place. Right, if I can find it again. Beg your pardon. I love, yeah, just one moment, people. Thank you. Thanks very much. Okay. CCQM discussed the proposal, meaning this new proposal, in April of this year. The majority of the participants opposed the change because the word doubt does not convey the notion that measurement uncertainty is in inverted commas, well defined limit of our knowledge of a value coming from a measurement, and may lead people to question the validity of the measurement. So we've heard a little bit about that in some of the comments and questions that have been asked. And Steve Ellison did, in fact, address this a bit. But I want to go further on. It was also noted that a major change in definition requires consultation of the broader measurement community to assess both intended and unintended consequences of the change. Then the question, what are the potential unintended consequences of the change, and have these been considered by the working groups? So let's start this time with Walter. Do you have a response for Robert? And, perhaps you could express some view on that at the same time. I'll then come to you, Chuck, once Walter's finished.
Yes, thank you. So I start from a statement there in Robert's text. Measurement uncertainty is a well-defined limit of our knowledge of a value coming from measurement. The point is that I just make an example for a multivariate measurement, okay, considering separately the uncertainties of the individuals is a very dangerous thing. So the right attitude is to consider the uncertainty of the ensemble. And I make you again the example of mass standards. If you consider in a list of values of your set of weights that you sent to calibrate to a calibration laboratory, if you consider the individual uncertainties and you do not consider the covariances between these values, you are prone to make catastrophic underevaluation of the uncertainties of a set of things, and you need to combine weights when you need to form something, say a weight of a greater value. So the right thing to consider in the case of a multivariate measurement is not the vector of n independent uncertainties, the values coming from measurement, as Robert writes, but it is globally the covariance metrics of this thing. So the natural counterpart to the standard measurement uncertainty in the case of a multivariate measurement is not a list of standard uncertainty, but it is a covariance matrix. Now, this covariance matrix for me is the expression of your doubt about the true values and their interconnections of the weights you calibrated. And with the current definition, you cannot consider this covariance matrix as a measurement uncertainty, because measurement uncertainty is just a parameter. So this is just good for a scalar measurement. And I cannot imagine, I cannot imagine a covariance matrix not being representative of a measurement uncertainty. So this is the first point. The second point, the potential unintended consequences of the change. Well, in my opinion, there are none, because, as I said, this is just a conceptual rearrangement of things, and we can have only benefits. Of course, we cannot see in the future. We don't have the crystal sphere, but this is my personal feeling. Thank you.
Thank you, Walter. Chuck?
Hey, thanks, Steve. Thanks, Walter. Thanks, Robert and the CCQM for your question. Unintended consequences. Well, you've already heard me talk about the unintended consequences having to do with having to rearrange several of the definitions in the VIM pertaining to measurement uncertainty. But I think we just heard from Walter. He's okay with that. But it is an unintended consequence. But the other thing is that, I mean, we have to ask the question, what kind of entity is doubt? What is a doubt? And we've heard from Walter, it's a feeling or a belief or a state of mind. Okay. And so as far as unintended consequence, it's that this term, which I tried to emphasize in my presentation, the term measurement uncertainty would change. The association of the term, okay, with the definition would change the nature, okay, of what the term measurement uncertainty meant. Okay, it would become a feeling or a belief, and not a parameter. Although I think, as I mentioned, Working Group 2 agrees also that parameters not optimal, so we'd be open to something else. So I guess that's an unintended consequence, that all of a sudden the term measurement uncertainty, it takes on a different meaning. It is used in a different way. And as I agree with what Walter said and what Steve has said, that, you know, as far as in the laboratory, this is not really going to affect people very, very much. It's not going to affect how they talk necessarily, but it's you know, perhaps going to impact how they, well, possibly will impact how they talk with each other. If they have to stop and think, okay, well, what do I mean when I use the term measurement uncertainty? Am I using it differently? So, but, you know, day to day, what's put on certificates, I don't think is going to change. So I hope that adequately addresses your question, Robert.
Walter?
Yes, it came to my mind about the unintended consequences. This definition has been for 10 years now in the NIST quality manual, and I'm not aware of unintended consequences in NIST. No catastrophes at all. So.
Okay, thank you. This isn't a backwards and forwards in a courtroom, so you don't have the right of response now, Chuck.
I don't need it.
No, you don't. I want to just, because many of these questions are now duplicated and supporting one or the other. So I don't think it will be productive to perhaps continue to answer any more questions, other than there's an interesting question here that's been posed by Martin de Groot. And I'll read the whole thing because I think it is quite an interesting idea at the end for both of you to consider. Terry Quinn, on the 20th birthday of the gum, I call it the gum. I know in Europe you prefer the gum, but the gum, you know, U is it's not But anyway, at NPL, suggested that the word uncertainty could be replaced by certainty. By the way, that's something that I favor. I wondered why we never started with certainty. We're certain. We wouldn't then be uncertain about it. But nevertheless, using the word doubt will cast doubt on the measurements. I think there's some tautology there, where measurement uncertainty was a new term and was defined in times where cynicism on science was different than now. Well, I question that statement. There are plenty anti-vaxxers around. I think that changing to certainty is difficult, but can't we relate uncertainty closer to the definition of accuracy, which is not quantifiable according to VIM 3, question mark. What is your new definition? What is in your new definition the difference between accuracy and uncertainty? Chuck, you want to start?
Yeah.
Walter, you want to start?
Okay, I'll be happy. I'll be happy to start. Yeah, that is a tough one. I mean, the idea of using certainty, right? How to use certainty. I mean, is very complicated. I don't know exactly how it's being proposed to use it, but certainly it would be good if a method could be developed for making whatever term is used more positive. So I agree with that, but I don't know exactly how to do it. But I think as far as, what could be an acceptable compromise here, if uncertainty isn't acceptable to people either, or doubt, then what kind of primitive might be used? I mean, we've talked about one way of making measurement uncertainty, still keeping it quantitative, would be to say something like degree of doubt, or degree of belief, or even degree of uncertainty, or level of uncertainty, or something like that, which would introduce a quantitative aspect, which perhaps could be a way around this issue. But that's not certainty, using certainty. And then I was there at that workshop, and I remember Terry saying that. In fact, I think I spoke right after him. I think that, but we're not. I mean, clearly, we're not certain about much, if anything. So Walter, I guess, gave a few things that are certain, but so I don't know how to incorporate certainty. But on the other hand, I think there could be a compromise in there to change the beginning, rather than starting with doubt or uncertainty, to make it level of doubt or degree of uncertainty or something. So that's the best I can do, Steve.
Okay. Walter, any thoughts?
Yes, of course. The last sentence, the last question is interesting. What is in your new definition, the difference between accuracy and uncertainty? This is a very good point, because, and Chuck knows very well as well on that. Essentially Working Group 1, complaints from people against the usage, which is widespread, of accuracy as a quantitative term. So accuracy of 5 in 10 to the minus 3 or whatever. And this is confusing, because you don't know what is meant by that sentence. So that's the reason why in VIM 3, correct me if I'm wrong, Chuck, the accuracy is defined as a non-quantitative issue. But I hear that in VIM 4, this view is prone to change, because Working Group 2 is probably inclined to acknowledge the usage of accuracy in the quantitative meaning. This is extremely confusing, both for people needing to know the performance of an instrument from a data sheet in which accuracy is used extensively, or from requirements in which an accuracy of blah blah is required. When Terry Quinn proposed that, I had a private exchange with him, and a possible proposal was to define accuracy as the reciprocal of the relative uncertainty. Okay. But the problem is that, again, measurement uncertainty, as it is defined, would you use standard measurement uncertainty or expanded measurement uncertainty that we know has severe limitations? It works just if the output distribution can be considered Gaussian or student T or whatever. So that's the reason why it was dropped. Yet we would be in favor of discouraging the usage of accuracy in a quantitative way. And when I say we, I mean all the people working in the laboratory and dealing with the specifications, data sheets, and so on, because this is extremely confusing. Thank you.
Thank you. Chuck, did you want to respond? I think you seem as though you'd like to.
Yeah. Thanks. I forgot about that part of the question about accuracy, and Walter's correct that we've certainly looked at that for the VIM4 for the next committee draft, and we do plan to acknowledge that the term accuracy is used both ways, in a non-quantitative and in a quantitative sense, and acknowledge that to make it acceptable, usable, the term usable to the broader community, and people just have to be clear about how they're using it. I mean, like Walter says, it's very common to see an accuracy class specified in an on the manufacturer's sheet for an instrument. So it is used both ways, and Anna Chinovkina, who chairs the group for Chapter 3 in the VIM4 Third Committee draft, has very clearly wanted to keep both aspects in the definition, and so, or at least keep the definition broad enough so that the notes can cover this. And we're doing that for several other entries in the VIM3. I mean, such as error, where error is used both in a quantitative sense and in an unknowable sense. So this issue exists for actually several other entries. But yeah, thanks for reminding me there, Walter. And
okay.
So thank you, Steve.
Thank you. Okay, I have one last question. There are lots of comments here, both Walter and Chuck. So I think there really is useful material to consider and to discuss and group and think about. But there is a question here that I think indicates perhaps that we haven't necessarily clarified from the new proposed definition, Walter, sufficiently. So Jesper Johansson has said, I did not understand the need to make the definition subjective. If the revised definition started with quantitative expression of doubt, many of the issues explained related to other VIM terms would be resolved or reduced. Can you clarify the need to make the definition of measurement uncertainty subjective?
Is it to me?
Yeah, that's for you, Walter.
Yeah. Well, you might want to share it with Steve or with Nicola, if you're not feeling like you want to answer it.
About the alternative, plainly and brutally doubt about, or expression of doubt about, here again we had lots of discussions within the working group. You remember, both you, Steve, Alexander, and Chuck, we had both a lot of discussions. Someone was keen to keep the quantitative aspect, although loving the idea of doubt or uncertainty, but expression of was something that would have been. Then it was, again, I had no strong opinion on that. This is a possibility, of course. The choice eventually was in the sense I showed, mostly because of the fact that the notes explain, in my opinion, very well what we intend. This is for the first part of the question, or for the first question. The second question, why do we want to keep it subjective? Well, as I said, I think it is a good thing to be explicit on the fact that complete objectivity in a measurement is impossible. I mean, impossible, absolutely impossible. A colleague used the term gibberish. So you cannot but hope to be completely The data cannot speak by themselves. If you reason, give me an example of complete objectivity in a measurement in science, and I will, with pleasure, forget about this subjective. Thank you.
All right, thank you. Ladies and gentlemen, colleagues, I think I'd like to draw this to a close because I think we now are into not really answering questions, but really more about stating our beliefs in either side. So I think this is a good opportunity to stop. Walter, you raised your finger. Because I know you so well, I'll let you have I don't know about the last word, but I'll let you have a word.
Now, there was a question that caught my attention by Peter Blattner. And yes, I think this can be easily answered. The question was something like, if you use uncertainty rather than doubt, there is no risk of circularity in the definition. This was one of the doubts someone had within Working Group 1, but we were reassured by people of Working Group 2, which are the experts on that there is no risk of circularity, even using uncertainty. That's all. Thank you.
Thank you very much. I see Chuck nodding in agreement, so he's not going to address that either. Robert, I wonder if we can put up the instructions for the poll, because I think we've had some good discussion, and while Robert is doing that, which he's now done, I'd like to just take the opportunity of thanking everybody for providing some really, I think, very useful information in the Q&A. And I will also say that I will, at the end, address perhaps how we will go forward, because as Martin mentioned, this is not seen as a vote, and if it goes one way, we're going to do one thing, and if it goes another way, it will be another will be done. I mean, this is a process, and we hope we will help to bring it to some conclusion. So on your screen, colleagues, you'll see there is a QR code, and there is also a URL, www.menti.com. So if you have access to a mobile phone and you can scan the QR code, you will it will take you to a page which says open your browser, and if you click on that, it will then take you to a page in which there is some pink with a green arrow and saying waiting for the host or something like that to give you the first question. I will delay here a little bit and allow people who are going to use their web browsers to go on menti.com, and the same will apply. You will have to click on, I think you'll have to click on the login, and then it'll allow you to give that code 86704800. I'll repeat that, 8670. And then 4800, I think you need a space between the two groups of 4. I'll wait a moment to make sure it gives everybody a chance to get on the page. And I have some spies from South Africa in the audience, so maybe they can tell me they've managed to get on the voting. That would be great. But as I say, once we get on there, Robert, in a moment, you can then perhaps go to the page with the two questions. Then we can come back to this page. You'll see. Perhaps you can move on one slide, Rob. Thank you. Whoops. Oh, okay. Sorry, we're on. Yeah, I think we've. Rob, can you share the screen again with? Thank you. There you go. We'll come back to the slide in a moment. You're going to get 2 poll questions. The first question will say, are you in favor of the proposed new definition of measurement uncertainty being included in the VIM4? And the second one will be, do you need more justification? In other words, did we in fact answer your questions? And my spy says that he's on the site, so we can go back perhaps to the whoops. Okay. All right. So if you scan the QR code on your mobile or you go on via the web browser, you should be able to get onto the first question. And Rob, can I suggest that you release the first question for answering? And it's now, by my watch, 13:27. And could we ask everybody who's in a position to vote, please, to do so? It would be really appreciated. I saw we got about 420 odd people online. We're not sure how many people we've got on live stream. We're counting the numbers rather than the percentage. So we've got some idea about whether or not everybody has voted. I want to encourage you all to vote. Even if you're not sure exactly what you're voting for, give us your vote. I mean, we really want to know that you were there and we kept you awake and we kept you interested. So we're up now about 350. So we'll just wait a few more minutes before we close the poll. If there are no more changes. Oh, it would appear that both questions are being asked twice, are being asked together. Okay, so both questions can be answered simultaneously, I guess. Perhaps you can just move to the next slide, Robert. Thank you. No, that doesn't seem to be the case. Okay, all right. So you should be able to answer both of them. Do you need more justification for this proposed change in order to form an opinion? Robert, can you confirm whether once we close the poll that you'll be able to show us the results?
I believe that's the case.
If you go back to the previous slide, what does that show us? It's fairly static. Okay. And if we go forward, I'm going to give us another minute to answer the questions because it looks like we've got all that we're going to get. And bear in mind, this is not a scientific endeavor, and this is not intended as a perfect answer. So we're well aware of the limitations of what we're doing. So please, bear with us. This is really an indicative kind of a survey rather than a precise or accurate or error-free or lacking doubt or lacking uncertainty.
I am uncertain on a thing, Steve.
Yes.
Yes. What the numbers we are seeing here are
Yes.
just those of the webinar, or we are seeing as well those of people attending on YouTube or LinkedIn?
Both. That was why we chose this platform. So
they sum up automatically.
Correct. Yes.
Thank you.
I think that was to try and avoid confusion, Walter. All right. Robert, another 30 seconds, and then I'm going to ask you to close the poll. Yes, I think we really are now pretty much, there are one or two stragglers, but I think, thank you, ladies and gentlemen, colleagues, I think we're pretty much there. This is actually a very, one must be complimentary and say this is really a fantastic thing. To get nearly 500 responses is wonderful. I would suggest this has been really successful from that point of view. All right, Robert, I think let's close the polling. Thank you. And as we draw to a close, the first thing I'd like to do is perhaps just ask Martin if he'd like to provide us with some concluding remarks, and then I will close the session. Thank you.
Thanks very much, Steve. My concluding remark is simply to thank Chuck Ehrlich and Walter Beek for coming online and exposing their views, to getting a snapshot from the community as to how people feel about it. Steve, thank you for organising this, and Robert in the background. We've seen the numbers there, around 270 yes and 140 no, and then very, very even on the question 2, is more information needed? So I give no value judgment on that, except to say that's the information, Chuck and Walter, for you to take on board. You're going to take on board the text of the Q&A. Some people are watching on YouTube and have entered information in the Q&A. We're going to capture that as well. All of that is going to be taken on board in the thinking by Working Group 2 and by Working Group 1 as well. So thank you from me.
Thank you very much, Martin, and thank you for providing your valuable time to us. I think it really shows a wonderful commitment from an organization that is really the key to so much that we do in measurement today. I just would like to say thank you on behalf of everybody, and echo Martin's thanks in that regard. I have to tell you, this is not an easy job to do, to try and contain you scoundrels, I virtually want to say, but it's okay. You've behaved yourselves, which is really good. And wherever you are, if you're going to sleep, have a good restful sleep. If you're having breakfast, enjoy breakfast. And if you're like me, going to have lunch, please have a glass of wine. That's for Walter. Anyway, ladies and gentlemen, I look forward to the next time. I'm sure there will be a next time. And maybe just one really small concluding thing to say. I think Walter, Chuck, and Martin, I think there's evidence to say that some other mechanism for obtaining input into this, besides the explanatory stuff, may be required. I think this may show that we need some additional information. Ladies and gentlemen, from me and from BIPM, thank you very much. It was a great session. Thanks a lot.
And thank you, Steve. Thank you, everybody.